and let's dive right in. So you've been working with SQL all week and schema design since last Saturday. So none of this should be too new to you. The overview is when you are designing a schema, step by step is you are first identifying the entities that you'll be creating tables off of, and then you'll be identifying the relationships between these entities. It helps to diagram a visual representation so you don't get too lost before you start writing your SQL. For our grocery store, we are going to want a customer, which will have a customer name and an email. We want to be able to give that customer discounts, and we want discounts to take the form of different discount rates based on a membership type. Next, we'll want to have a customer profile, which will essentially tie that membership type to a customer. And then we'll have items, which are basically your grocery goods, and customer orders, which are orders of these items. The relationships are, we will have a customer that has a single customer profile. Customer profiles can have 0 or 1 references to a membership type discount. So that's a one-to-many relationship. Discounts can belong to many customer profiles, and items can belong to many customer orders, and customers can have many customer orders, which are all many-to-many relationships. But in PostgreSQL, we are going to have the additional step of having to create an order items table to link the items to customer orders. And once we revise our entity list to include that, the updated relationships will include items belonging to many order items and customer orders belonging to many order items. And if all of that sounds like a mouthful, because it is, this is where quick database diagrams comes in. So given our requirements, we are going to hop into quick database diagram, and we're going to start writing out some basic SQL. Have you all used this yet? I know I introduced it last week. Okay, cool. So now you're familiar. I showed you last week that you could import SQL straight up into here, but you could also just type it freely like so. Syntax is going to be a little different, but it's still pretty intuitive. So we're creating a customer profile. Or let's start with a customer, actually. Start with the customer. We'll give it a little line break, and then we can start defining the columns we want in our table, like a name, which is going to consist of alphanumeric characters. And we'll give that a limit of 100. And I think my syntax is already off. Let me review my notes real quick.
I think it's just one hyphen.
It's just one hyphen. I don't think it's the hyphens that's the matter, actually. I think it's
Yeah, Julius, it doesn't like that. So just put the varchar, don't put the limitations. It just doesn't like that.
well, I just deleted a space and it seems to like it now.
Oh
So.
no, now it's working. Well,
Right.
never mind.
Yeah, I guess it's finicky about spaces in between your the name of your column, and actually no, the space was between varchar and 100. But
Yeah, it was between that's what it was between. Yeah.
now we're going to want an email, which will give a limit of 255. And if I remember correctly, by default, quick database diagrams forces all of its columns to be not null by default. So if you want to give the column the ability to be null, you have to specify null. Let's see. Next, we're going to want a discount. And we will give this an ID, and it's going to be a primary key. So PK for primary key. Then we'll want a %, which will be an integer. And we'll also want a membership type, which will be a string. It will be things like gold, silver, etc. And we will then, It's not to add that yet, actually. We will then create a customer profile. And this will also have an ID, primary key, and then we'll want a customer ID, which we want to map to the customer. So we have our customer profile. We want the ID to belong to the customer. Oh, wait, I forgot to give the customer an ID. So let's go back to the customer. Let's give it an ID, which is going to be an integer, and it's going to be a primary key. That way it will automatically be generated by Postgres. So now we can map the customer ID of the customer profile to the ID of the customer. And we'll want to do something similar for membership types. We want a membership type to reference the ID. So let's call it membership type ID. And this is going to be another integer. And we will then map this to our membership, or I should say our discount ID. Next, we will want customer history. Actually, I'm jumping ahead. We don't want customer history yet. That's part of the challenge. We want items. We're going to give this ID just like everything else. We will give this product names, and we will give it a cost, and then we will give it, we'll give it that later. Now we're going to do customer orders, I believe, custom orders. And we'll give this another ID. We'll then have a foreign key. So customer ID will tie to the ID of the customer. And then we will have order items to link the customer orders, or I should say to link the items to the customer orders. And so let's create one last table. We are going to have, like usual, an ID. Now we're going to have an order ID and an item ID because we want this table to reference both the customer orders and the items. So now let's just link everything up. And this should be a good visual representation of what our database is going to look like. With that, you could either take a screenshot or export the image as PNG. And from there, we will switch screens actually. From there, we'll be able to start querying the database. Actually, I won't switch screens just yet. We're going to go through the rest of these slides, and then I'll jump into showing you my terminal with this database. So similarly, this is what our diagram looks like. And from here, we are going to insert some SQL to create our tables. And this is all inside the grocery store DB repo, which is linked in today's README. From there, we are going to start running some queries to start testing for whether we could access different parts of this database. Okay, let's see. We are on here. Right, here's SQL implementation. And then from here, we would be running queries. We'll get to that in a bit, but I want to go over more specifically various types of joins and various ways of running queries. So starting with joins, you should already be familiar with these. So there are inner joins, left joins, right joins, and full outer joins. This table should be available in one of the READMEs from these past few weeks. But basically, if you want to return a certain amount of information, you want to use the right type of join. And you could also use, a where clause to exclude data from one table, or data, I should say, that is in both tables, if you want specifically, for example, data that's only in A but not in B. From there, we have regex matching. So when you're writing your SQL code, you can write a where clause to filter out the information. So this is what you do after you've defined which tables you want to include in your search using joins. There are two ways to go about searching in Postgres. One is to search through regex, which is regular expressions. And the other, which we'll cover in a bit, is pattern matching. But regex is going to utilize a tilde operator. And then with that tilde operator, you could use a star or a bang symbol to transform it from a case-sensitive inclusion to being case-insensitive, or being an exclusion, or being a case-insensitive exclusion. So for example, if you were to write select star from customer C, where c.email tilde Google, we will be pulling all data, all rows where the customer email contains Google. Here is an example of the tilde versus the tilde star. We have a case-sensitive search up here. And so IS is only returning lowercase is's. When it's case insensitive, it will now also return capital IS. So simple enough. Similarly, you could use the bang to negate results. Here we are excluding com from our search, so we are pulling up all other types of emails. There are additional characters you could use with regex to give you flexibility in designing your search. An up caret will allow you to search for a pattern at the start of a string. Similarly, the $ will let you search for a pattern at the end of a string. And you could also search for numbers, and you could search for characters such as white spaces. And a few examples of that would be like in this screenshot, we have net appearing in a few different emails. We have net appearing in net vibes, url.net, and liveinternet.ru. If we only wanted a .net email, we could type tilde net $ to specify that we want net to be at the end of the string search. Similarly, with an up caret, we can specify that we are searching for a string at the beginning of a value. And this will take us to a good point to be made, and that is that there are going to be various ways to go about finding the results you want to find. And so it's not about exactly like one method being better than another. It's more about just understanding each of these variations and knowing how to use them effectively. In this case, we're pulling the same results with two different searches. Here we have a case-sensitive search where we are searching for BE at the beginning of a value. Here we have a case-sensitive search, and we're specifying that we want B and E to begin with an uppercase B. So they are different queries, but they return the same results in this instance. Let's see. Similarly, you can exclude, similarly, you could, what was I going to say with this?
Case sensitive?
Yeah, I guess it's just another case insensitive example. Yes, in the second example here, we have a name search where we are searching for a case-sensitive B and E. And again, it's returning Isabella. And it's not returning the other names because they all have a capital B. Next, we have the example where we are pulling up values with numbers. And so these are all the emails that have a number somewhere within them. Similarly, we could pull up product names that have spaces using a \s. The other way of searching for matches within Postgres is to pattern match through a like operator. So like operators will match for string patterns. And similarly to regex, you could have case-sensitive inclusion, case-insensitive inclusion, case-sensitive exclusion, and case-insensitive exclusion. One thing to note, though, is the syntax for using like is quite different from regex. It's simpler in that it doesn't use characters like up carrots, dollar signs, etc. It really only utilizes two wildcards, and that will be the percent symbol and the underscore. Oh, and I see a question, Damon. I'll get to that in a bit. The advantage of using regex versus like. We will get to that in a bit. But first, let's go over like in a little more detail. So in this example, we are searching for customers where the email contains the letters THE. Because this percent symbol represents 0 or more characters, we're essentially telling this we want the THE to be in the middle of our value. Underscore represents a single character. So in this instance, we are telling it we are searching for a value where the first character can be anything. And then our next character is going to be an A. So what that looks like is this. When we specify underscore A, we are pulling up the results where A is the second character. We could also repeat the underscore to designate a search where we want it in the third position. So 2 underscores means we don't care what the first 2 characters are. They could be anything, but we are looking for a pattern that is similar to this. And again, the percent sign allows you to either start, end, or place a search in the middle. So in this instance, we want A to be the very first character and anything else that follows. And in here, we want things that only end with .edu. So regex versus pattern matching through like. Really, at the end of the day, use either or based on your preference or based on the use case. There really is not a significant difference. You can pull the same results, you utilize them in the same ways. There are really just a few, let's say, advantages and disadvantages. Let's say with regex, it could be harder to read parser reply because you have to memorize more symbols. And that's not the case with like. Like is optimized to use only the percent sign and underscore wildcards. And in that regard, it's easier to understand, but less flexible. It won't allow you to do many more things. It's optimized to short circuit, which means it will fail a lot more quickly than regex. So regex will allow for additional functionality, including the use of advanced functions like replace, substring, split, and it, at the same time, because of that, is going to be a little more resource intensive. But at the end of the day, the difference between the two is minimal. You basically, as long as you understand how to use each, what the differences are, you are free to do as you please. One interesting thing to note is that like is actually just a text equivalent to the double tilde operator. So this is all exactly the same thing. When you're typing like, you could similarly type double tilde and it will do the exact same thing. So here in this example, we see that this first query is using a single tilde. So it's saying, I want to look for a regular expression. Well, passing it an A and a percent symbol doesn't work because that's syntax for the like search. So when we use like, then we are able to return patterns following A and the wildcard percent, which again means 0 or more characters. And similarly, you could just type double tilde to execute a like search. And that pretty much covers it. Let's switch over to the challenge. Does anyone have any questions about any of that, by the way? Cool.
Can you use like look aheads and look behinds and everything else in regex as well?
Yes, you can. And there's actually, I personally have to use a regex builder all the time. I cannot memorize regex to save my life. So there are a lot of tools online that you could use to help you determine what regex expression to use for the expression you're looking for. So this is a really nice example. Like you could toss a string in here, and then you start typing out your regular expression, and it will immediately return results. Saying, let's say this is an example. Let's look for, are there any numeric characters? There are not. What if we added a numeric character? It will find a match. 1, 2, 3, and it updates live, so it's very reactive, which is really nice. So when you're referring to look aheads and whatnot, I think this would be a powerful tool in allowing you to craft your search to return exactly what you're looking for. Okay. The challenge is really an extension of the grocery store example today. So let's actually maybe backtrack a bit. I just want to see if I'm missing anything in the README. We did this, and I think all the README really covers is, it runs through a few queries, so we could run through these real quick. In this example, we have select membership type, % from customer seat, and we're joining the customer table with the customer profile table, and we are linking them by telling it that we want the ID from the customer table to match the customer ID of the customer profile table. And now we also join a discount table where the membership type ID from the customer profile table will match the ID of the discount table. And then we give it a where clause. We want results only for the name Dalton. And this is what this query will return, giving us his membership type and the percentage discount that he can have on his purchases. And then we could have this query here to return a count of all the different membership types. And this will let us know that we have 8 silver, 10 bronze, 9 gold, and 23 members without a membership type. Advanced queries, I'm not really sure why they added these if they didn't want to worry about them. I guess you're free to dissect these on your own. But I went ahead and created this challenge where it's, again, exactly the same database, the same data as the README. So you'll start by forking this, cloning it locally, and running your container, your Docker file, running the SQL to populate the database. And then the first half of this will be to run some query exercises. You basically will use a combination of joins and where clauses to answer these following questions. So you could write your SQL queries into the solution SQL file and then push them, or you could write them straight out of your terminal, then paste them into a SQL file later on. Afterwards, you'll follow this schema exercise where we will update the existing schema to add things like quantity for the number of items that may be in an order, or maybe if we want to give customers the ability to accrue reward points. You can do all of this within a quick database diagram, but if you want to go the extra mile, the stretch goal is to actually write out these changes through SQL and then toss them into the schema update SQL file. So that is the first challenge for today. I will let you all work in groups, and then later on, I will close out the breakout rooms and you can jump into Blue Apron schema. Like I said earlier today, there's not going to be a break in the middle. I'm going to let you move at your own pace, and then we will reconvene at the end of the night. 8:45, we'll come back. We'll go through the grocery challenge where everyone will share one query. There's enough for everyone. And Then we will look over the Blue Apron schemas that you've all created. Like I said at the start of this is essentially everything that you need to do a good job on the assessment this weekend. And I think that is my reasoning for letting you work on the first challenge as a group, but making the second challenge a solo challenge. So we will open up breakout rooms, and then at, let's say, 7:15, maybe 7:30, I will close out the breakout rooms. If you need more time for the first challenge, just ping me either on Slack or just say so inside the Zoom chat. Or I guess like the usual, how we've been doing it is you'll be in your breakout rooms and just start heading back at your own pace. Once everyone's back in the main room, that's a good sign that you can move on to the second challenge. If you get through the challenges early and you have any other additional concerns about Docker or anything, ping me or Tiffany once she gets here, and we could hop into a breakout room with you to work through anything that you might need assistance with. Any questions? Awesome. So I will open up breakout rooms and you all can dive right in. Feel free to take a quick break if you want, but from there you are all on your own until 8:45.